Okay, so my name's Adam, and I'm at the University of Leeds, and my project title, I'm in the first year. My project title is Death in the Oceans, Extinction Risk in the Marine Realm. So the aims of the project are to quantify the primary drivers behind extinction in marine plankton by direct sampling of the foraminiferal fossil record for the Neogene and Quaternary, and determine whether there's any consistent biotic changes which might be occurring, which could be used to determine any future extinctions like caused by anthropogenic climate change. So the background is that, as we know, extinction rates are the highest for the Cenozoic period, and it's been accompanied by a steady rise in oceanic temperatures for the last 2 decades, at least since the Industrial Revolution. And models are showing us that over 90% of the global warming we've experienced since the 1970s has gone directly into the oceans. So what's the result of this warming? Well, the injection of heat and carbon dioxide into the surface waters causes a reduction in the solubility of oxygen in the waters, and also causes what's known as intensified oceanic stratification, which limits the amount of nutrient supply moving into the surface waters and oxygen moving into the bottom waters, which is known to cause expansion of oxygen minimum zones, which we already have evidence for today. So why are we looking at planktonic foraminifera? Well, their calcium carbonate tests are sourced, the chemistry of which is sourced directly from the seawater, so we get a reflection of the delta-13 carbon and delta-18 oxygen, which gives us ideas about the ecology at life, and also they're highly abundant within the fossil record and also the geological column. Also, they exhibit stratification through the water column, so if we do get this expansion of OMZs, then it's detrimental to many of the forms which migrate in the later stages of their life strategies. And finally, their fossil record is, the species level fossil record of planktonic foraminifera is as good, if not best, than any genus level fossil record of macroinvertebrates. And the thing we're focusing on for the project is these terminal branches within the Neogene, using systematic sampling to test a number of hypotheses. The hypotheses concern geochemical, morphometric, and biogeographic range analysis. So within geochemistry, we'll be looking at delta-13 carbon, which, as we can see by this chart, tends to have an enrichment into the surface water. So within these terminal branches, if we're seeing a steady change within the delta-13 carbon ratio, it might be a changing of ecology as a response to biotic or abiotic drivers. And then we'll be looking at oxygen as well, which we need to disentangle from the enrichment caused by glaciations on the Earth by using MGCA, which is completely independent of the amount of ice on the planet. And then also morphological analysis using a morphometric program to look at changes in general dimensions, sphericity, and possible addition or loss of chambers within these terminal branches. And then finally, biogeographical range analysis, where we know that after speciation we do get general migration towards the tropics, but we want to determine whether or not there's a consistent migration prior to extinction, and then combine these hypotheses together and see if there's a ubiquitous signal throughout the Neogene before extinction occurs. Thank you.